So what is the displacement? Kalau kita project ke atas ni, ke mana dia nak pergi? Kan? And then in our course, we limit our discussions where we assume that between the 2 point, the displacement between the 2 point will varies linearly. Maksud dia akan berubah secara linear daripada point 1 dengan point nombor 2 ni. But in the real case, it may not behave like that. Dia mungkin boleh jadi follow to certain parabolics lah kan, usually in parabolics lah, ataupun polynomial punya curve. So if we use linear, but in the reality it behave like a polynomial, then kita dah ada small error dah dekat sini ni kalau kita tengok kan. In real sepatutnya value dia dekat sini, tapi kita punya prediction we assume only linear, so we have some error in our calculation. But you must understand, even though we in our course we limit our discussion to the linear variation between the two points, but in the real case, okay, it may not behave, the structure may not behave in terms of dia punya deformations tu apa semua tu may not behave linearly lah. So ini sometimes ago saya tunjuk juga dalam kelas what will be happens if this structure behave according to cubics punya shapes ataupun polynomial punya shapes. Tapi apa tu, benda tu lebih kurang sama je, cuma dia ada extension in term of dia punya mathematics sikit. So dan kita pun tak tanya dia dalam test or exam, so kita apa tu stick to the linear sajalah. Alright, now let's look at this natural coordinate and shape function, which is this topic will actually relate to the yang kita discuss tadi, to interpolation. Alright, interpolation. So the natural coordinate, saya baca dulu dan saya explain. Consider a single element. So daripada elemen yang kita ada banyak tadi tu, saya ambil je satu elemen, any elements. So it mentioned there, local node 1 is at distance x1 from the datum. So let's say this is kita punya elemen number 1, tapi dia punya datum dia tu located maybe somewhere dekat sini kan. Dan from datum, and node 2 is at x2 from the datum. So ni lah distance dia from the datum. Alright. So x2 from the datum, which is this datum is a fixed point. So we measure the points ni from the same datums. And then we can write our elements in other coordinate system, which is known as natural coordinate system. So instead of kita pakai X, which is a Cartesian coordinate system, then we can represent kita punya axis kita, which is dalam bentuk ataupun dalam format natural coordinate system, which is given by Z lah, kat sini kita panggil dia Z, XI, Z. So as you can see here, if we have two nodes, one element and two nodes, the natural coordinate system itself is in between -1 and 1 only. So Kalau tengok dekat sini, on the left hand side of our element. So this is our element. On the left hand side, so this point, our natural coordinate system, the z is equal to -1. Ni kan, -1. And on the right hand side of our element, dia punya z dia adalah +1. Then if we take the midpoint, so we can say that z equal to 0 because dia dekat the midpoint. So 0, +1, -1. And this value will be remain the same. Let's say saya ambil kita ada structure tadi kan. Kita ada structure, ada banyak elemen. Kalau kita ni node 1, 2, 3, 4. Kalau saya ambil yang ni pun elemen number 1, 2, 3 kan. Okay, elemen number 3. Then if I redraw the element number 3, which is connected within nodes 3 and 4. So this is my nodes number 3. So in terms of dia punya coordinate, natural coordinates dia is always -1 on the left hand side and equal to +1 on the right hand side. So this is according to the textbook that we use to generate these presentations for use lah. But if you read other textbook, you may found that this natural coordinate system will be can be written in different ways. Ada sesetengah textbook tu on the left hand side kosong, on the right hand side 1. So dia tak kisah. Tapi untuk kita punya approach, I think we have to make it consistent. So z always -1 on the left hand side and +1 on the right hand side. So tak kira elemen 1 kamu consider elemen 1 ke, elemen 2 ke, elemen 3. So value dia sentiasa sama je untuk semua elemen. Then from there we can write the natural or intrinsic coordinate system z, which is given kalau kita kalau kita combine ni dua ni. Then we can write the z, which is can be represented by 2 over x2 minus x1, which is x2 minus x1 ni x2 kita minus dengan x1, which is will give the length of this element. So x2 minus x1, which is actually equal to the length of this element. So yang ini adalah the length of the element. And then multiply by x. X ni maksudnya any point. Kalau kita ambil midpoint, dia akan jadi midpoint lah kat sini. Kalau kita nak tahu what is happening there, then we supply the x value there, then minus by x1, then minus by 1. So actually this apa yang berlaku kat sini adalah macam linear interpolation je ni dekat sini ni. Macam linear interpolation. So it's mentioned that the z coordinate will be used to define shape function. So kita ada natural coordinate system, kita ada shape functions. So shape function ni dia akan menentukan yang dia punya apa tu the linearity of kita punya interpolation tu nanti. The shape function required to establish interpolation functions. Shape function to establish interpolation functions. Kalau linear interpolation, so dia ada bentuk shape function dia tersendiri. Kalau kita assume structure kita behave as a cubic punya apa ni shapes, then dia ada shape function dia tersendiri untuk cubic punya interpolation function. So yang ni boleh faham natural coordinate system, which is basically kita boleh katakan kita boleh convert daripada Cartesian kepada natural coordinate system, which is Z boleh diperolehi daripada equation yang kita ada dekat slide ni, dan value of Z adalah sentiasa negatif 1 on the left hand side dan sentiasa positif 1 on the right hand side of each element. So first topic ni kita slow je dulu. Kalau tak ada soalan, saya proceed. Kalau ada soalan boleh tanya. Okay, tak ada soalan. Okay, saya proceed dulu. Okay, this is the shape functions. So this the displacement field. Okay, kita panggil displacement field, which is given by U. So kalau dekat nodes tadi, kita representkan dia sebagai, let's say this is our element under applied force. So kita expect bila kita punya structure dikenakan external load, so dia mungkin akan ada pemanjangan kan, which is given by Q. Dekat sini pun mungkin ada Q. Sorry, let's say ni node 1, ni node 2, so Q1 dengan Q2. And then ini adalah pada nodal point. So in this slide here, what is meant by displacement field dekat sini adalah the displacement yang berlaku di antara dua nodes ni. Let's say somewhere dekat sini. So kita boleh gantikan dia sebagai the U ataupun displacement pada distance X. Let's say X kita start daripada sini juga kan. So pada point X ni. Pada point X. Alright, the displacement field UX within the element is unknown. So bila kita solve when we solve the system of linear equation K Q equal to F, this Q actually is the displacement at each nodal point. Maksud dia dekat sini lah, pada nodal point ni. Ini adalah Q yang kita dapat daripada system of linear equation. Tapi displacement within the two nodal points kita tak tahu lagi. Kita tak boleh dapat daripada system of linear equation. And then for simplicity, it is assumed that the displacement varies linearly. So this is the limitations of our course. But you have to understand that the structure may not behave, dia tak sentiasa behave secara linear. The displacement varies linearly from node 1 to node 2 within the element. Dia macam ginilah. Physically dia mungkin berubah macam gini kan. Tapi in our case we assume apa yang berlaku pemanjangan di antara sepanjang kita punya elemen ni, di antara dua nodes ni, dia berubah secara linear. Okay, since we assume the displacement dia varies secara linear, then we can establish a linear interpolation function to represent the linear displacement. Okay. Alright. To represent the linear displacement field within the elements, which is the shape functions for the linear interpolation, which is given by n1 and also n2. So kalau kita tengok dalam n1 ni, kita ada term z, 1 minus z over 2 for n1, and 1 plus Z over 2 for N2. Untuk linear interpolation, we only have two values of N. If we considering our structure varies in cubic shape or polynomial, then we may have another terms lah, N3. So that's why we are not going to consider in this in our course. So at least at this stage, we should understand that we have first is the natural coordinate system, which is given by 2 over LE multiplied by x minus x1, and all of this we minus by 1. And then the shape functions, which is n1 given by 1 minus z, which is this z here, divided by 2. And then we have another z, sorry, n2, which is given by 1 plus z over 2. So this is in term of dia punya mathematics dia. Nanti kita akan tengok macam mana kita nak pakai ni. Kan? Kenapa kita nak kena guna benda ni kan? Dia ada sekejap lagi. Ataupun dalam kita punya meeting besok kita akan discuss benda ni. Sekarang ni kita cuba faham dia punya fundamental concept of the finite element itself. Which is apa yang kita buat benda ni selepas kita dah apa tu dah set upkan body condition, kita dah set upkan dia punya material, kita dah set upkan dia punya force, applied force, and then kita dalam proses dah nak solvekan system of linear equation tu sebenarnya. Alright, this is the shape function. Alright, so this is how we can use the shape function tadi tu. So when we solve the system of linear equation, as I mentioned earlier, we can obtain only the displacement on the nodal point. So this is our structure. So when we solve the system of linear equation, it will give us Q1 for the nodes number 1, and then Q2 at nodes number 2. Kalau kita nak tahu what is happening there, kita tak tahu. How we can do this? How we can obtain what is happening there in terms of the displacement? Sebab displacement dekat node 1 dengan node 2 mungkin lain. Dengan dekat sini mungkin berbeza. Tapi berapa? Exactly. So in order to obtain the displacement within the two nodal points, we can use this equation, which is given by ux equal to n1 q1 n2 q2, where the q1 and q2 must be solved first, which is that mean dekat sini kita dah solvekan system of linear equation, dah dapat, kita dah tahu the value dekat sini, kita dah tahu the value dekat sini, then baru kita boleh solvekan dia punya field displacement dia. Baru kita boleh tahu apa yang berlaku di antara dua nodes ni. Then we have N1. So Q1 and Q2 ni adalah the calculated. So this is a calculated displacement. Kalau kamu tak solvekan system of linear equation, kita tak akan dapat ni Q1 dan Q2. From the KQ equal to F. So we know that N1 equal to 1 minus Z over 2, N2 equal to 1 plus Z over 2. Kita just substitute. And then dekat bawah-bawah ni actually we try to simplify the equation sahaja ni. Dia tak ada apa pun. N1 and N2 we lump together and put in this metric form. And then Q we put it in the vector form. So N actually contain N1 and N2. Q, which is contains Q1N and Q2 transpose. Actually kat sini dia tak ada apa lah, just to simplify from U equal to N1 Q1 plus N2 Q2, and we can rewrite it in another format, which is in metric form, which is given by U equal to N multiplied by Q. So similarly, we can use this the shape functions tadi untuk dapatkan the coordinates, in between the two nodal points, which is sebab kita tahu that the shape functions n1 and n2 representing the linear interpolation kan. So when we apply let's say we know x1, we know the x2, and then we know the value of z for the structure, and then we can obtain the x lah. What is the coordinate of x in the Cartesian coordinate system. So kita boleh guna juga the shape functions and natural coordinate system tadi tu untuk macam kita work in reverse untuk dapatkan the x coordinates. Alright, let's look at example. So this is an example to show the usage of natural coordinates and the shape functions. So let's say I just took one element from my structures. Kita dah discretize dia, mungkin ada banyak elemen. Then we just take one element out of it. And then we know the coordinates of each of nodal points. Let's say from the datum, nodes number 1 is located 20 inch from the datum. So datum kita mungkin somewhere dekat sini. And then nodes number 2 36 inch from the datum. Then from there, we can evaluate what is the value of z, n1 and n2 at point P. So let's say this is the point of interest. Kita nak tentukan kemudian nanti berapa sebenarnya displacement pada point P ni, QP kan. Tapi sebelum kita dapatkan QP, kita kena tahu dulu what is the z, n1 and n2 at point P. Sebab koordinat pada point P kita boleh tahu kan, which is let's say in between the 2 point, between 20 and 36, we pick x equal to 24 inch. So untuk A, we just straight away substitute in the natural coordinate system untuk dapatkan z pada point P. So 2 over the length of the element, 36 minus 20, and then x 24, x1 20. Tapi as we can see here, refers to under the this then loading. From there kita dapati under this loading, z pada point P which is negative 0.5. Jadi kita dah tahu kan this bar ni z dia akan dia punya on the left hand side of element is ataupun body condition biasanya, and kita tunjukkan on the right hand side of kita punya element it will be always positive 1. So kalau kita ambil the midpoint, so kita punya z equal to 0, and in this case at point P, it's likely this point located at the